Okay, I'm back. Gonna be streaming some Go stuff. Let me get this link out. Yep. Some yeah, what? Let's see, do I have a prototypes? Let's see, I'll make a prototypes repo. I'll put this screen on. And I'm going to try and use VS Code. Let's see here. GitHub. So see, is it gonna leave my last project open? I don't really want that. Is there a way to close this? No. Okay. Okay, leave me alone. That's strange. Add folder, add, well, shit. How do you make a new workspace? Open editors. Let's see, add folder to workspace. Try it again. Okay, nope, I didn't want that. Let's see here. I don't know. New window. And then what? Okay, open a folder. Okay, kinda. It's weird. Okay. Alright, I'm gonna actually now create a directory here called supervisor, and in it create a file called readme. So this is a it's not like your everyday supervisor, because it's not gonna have a lot of fancy functionality. This is a supervisor made to run daemons kind of alongside your main process. So this would be a component that you could use in a program to run other daemons, either as plugins or whatever. So just trying to think out some of the specs here. So scripts and executables live in a directory. It watches the directory, and when it starts all executables. Ender as named daemons. A log mode allows their logs to aggregate into the parent process. Standard out, just parent, standard IO. Out there. If they, so unlike, and so this is actually not like most supervisors, I guess, but on unexpected exit, it'll try to restart several times and then leave it, and it'll write the recent log output to a file, because I think in normal operation you're not going to have it showing all the output in the parent process, because you're kind of assuming that these things generally work until they crash, and then if you wanted some other mechanism to get their output, I'd considered something like maybe an HTTP interface to specific daemon log output. I just didn't want to deal with log files. The only time I want to write a log file is when crash happens, because that's when it's actually kind of helpful. Yeah, and then leave it. But on file changes, basically on directory changes, it'll reload or start new daemons. What else? Try to come up with a better name for this. Maybe like I'll call it a sidecar supervisor. Okay, watches directory, starts all executables, and directory is named daemon, so we'll just use the name of the executable or the script, probably trimming any file extensions. Log mode allows their logs to aggregate into the parent. Maybe in development, that's what you want. Or maybe that's what you always want. On unexpected exit, I'll try to restart several times and then leave it. And then write the output to a file. Let's see, on directory changes, it'll reload and start new daemons. So some of the code for this, see, I don't know where the latest version of this is, but let's see. Maybe it was actually in Glider Labs, Com Lab. Nope. So most of this is you know, really built around the built-in exec command package. I'm really curious how people test that. So I wonder if we could look at some of the tests that they have. Helper command. Yeah, I've seen this. So it's actually using its self for the test that it's going to run, for the command that it'll run. Example test. This is an example. Our test main, something like that. Isn't a real test. Okay, so this is the thing. Okay, very interesting. Kind of defining all its little. It's actually implementing a lightweight cat and stuff like that. That's funny. Oh, this is actually a mock. Right? It's like kind of mocking out a bunch of existing stuff. That's pretty cool. I guess let's start with the tests. Let's see. Supervisor test. Whoa. What is all this? This is not true at all. Or maybe it is. Huh. Okay. That's my path. I'll do this myself. Huh, okay. Alright, yeah, install. It's already installed. This is a placeholder thing. I guess I can get rid of that. Got this dope ass terminal here. Okay. Go returns, not available. Do it. Sweet. We're gonna spit that out all the time. Yeah, it's rich as music. I think this is still Hyperlight Drifter. Alright, let's do go def command. Sure. Give me all this stuff. He's working at the Hyperlight Drifter company. Alright, let's try this. Actually, this is not, well, I mean, I guess I could just... yeah, I can kind of see. Kind of look like that. Undefined. Test env. What is test env? Where is that? Test env. Internal test env. Well, I don't know what that does. I don't think we need it. Is it, go test? Is it, what's it doing? Oops. Okay. How do I get it to do that on save? What is all this? Maybe it would just, let's see if the test fails, if it shows me something else. No. That test should fail. Golang. Run tests. Don't save. Flow can be enabled in settings. Alright. So we got some settings to fix up. How do we we fuck with settings? It used to create a font, you know, user settings, workspace settings. Okay, so then it creates that file. Okay, getting used to this. And go. All right. Build on save. Compiles code on file, save using go build or go test. Right, it is. Each file save the packages. Ah. Format on save would be cool. Is that in here? Format. Format on save. I guess they're in alphabetical order. There's not. I mean, test on save? Okay, true. Can't do that here. Test on save. Workspace settings. True. And let's see what else. By default goes the tool use. Okay. All right, let's see how that goes. Looks like it formatted. I mean, it's compiling, but not running the test. Build on save. That my playground. Test about test flags, test on save, just time it out. Not available in Windows. Use Go language server from Sourcegraph for hover duration. Do I have to, what, close and like come back? Is that the deal? Because it was not testing on save. Oh, now it's testing on save. Okay. That's okay, cool. Okay, what else? Let's see. Although, you know, it's funny because I'm realizing I probably don't need to test this way. Let's see, we have a type. exec. Yes, let's see how people do it. Okay, they're just wrapping it in. I mean, this is kind of. Wait, what? Yeah, I mean, they just got this. Okay, whatever. Let's see what you have to say. Oh yeah, it's very Go is to define your own interfaces on your end on what you expect. Because as long as the other end implements it, it's fine. So, CS Major 20, thank you for following. Feel free to say hi in chat, ask me about what I'm doing. I definitely talk more when I'm getting asked questions. Right now I'm just trying to see how other people are doing testing when using the exec package, because you could, it seems like everybody's actually running exec. But to me that seems kind of weird that they're implementing the interface. I don't know. Test commander. Because at the end of this, what am I not following here? This is like, if they're always calling this, they're not switching this out with anything else that implements this interface. If they were to implement something else with this interface, test commander. I mean, I'm assuming that they re-implement git head hash because this is just using it directly, so. All right, what else we got? Is that Curator? Curator. Thanks for following and hanging out. So I'm trying to figure out yeah. Me too. Then it hit me. Okay. Yeah. I guess it's like, why not? Like, anything else is more complicated, huh? Well, okay. I'll keep going with this method then. So some other things about implementation details. So we've got the things I'm kind of looking into here. Testing with exec command. So we kind of have that. I think most people implement watching files with a loop. Maybe there's some other good, because I don't necessarily know if I want a dependency on something that uses sys rather than syscall. Cool. It's a fork. Okay. I think I used this before. Watcher, events. Starts watching for operations on the named file. If directory is named, operations on files in the directory, but not in subdirectories, will also be reported. If the file has been added before, calling add again updates the set of operations being watched. So op is a bit mask. Okay. So new watcher has events. So close window. This is new. I don't think I've used this before. I like this API. I'm surprised there's not an example. I guess I passed an example that was in the tests. So we set up the watcher and then watcher event. Okay, so just looping over this channel. I see. Oh, and there's errors. Interesting. Okay. So I'll probably want to use this. Let's see. So this log aggregation thing is kind of an interesting problem. You want to, let's see, what was that? Foreman, Roku, it was in Go. What was that called? Let's see, who wrote it? Oh, that's nice. That's pretty cool. Man page. Yeah. Although I wish it would have yes, $. For Go. That's what I'm looking for. So this is what I was using. This kind of does something very similar. Yeah, it's got this interesting color text, huh? It's got this interesting Let's see, command. No, that is talking about this command. Curious what these look like. Forget it. Blah, 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 blah. Monitor interrupt. Yep. Start process. What's this new process? Where's that? It's created some kind of abstraction in here. Print it out, get standard out. Start a line reader. Let's see, pipe weight. Okay, so that's a weight group. Name of the thing. Index, I guess, which is just a number. I see. Oh, of. What is this? This is an output, an outlet factory. Sure. All right, start. Oh, what is this? Tear down, forego barrier. I think, okay. What is PF? Read proc file, I see. Gives us a proc file. I want to see proc file now. I feel like I've written this before too, but okay, so what's so special about this? Shell invocation command. What the hell? P and as array. I've got a nice little environment abstraction here that's convenient. I don't know why it's a lowercase thing there, but platform specific init. Find processes. Wait, what? Group. Oh, like a process group. Doesn't command already have signal? Why is he implementing this? And what is this all about? -1. Wish there was a comment here. Add error handling to signal. Okay. Interesting. Oh, yeah, let's look at barrier. Borrowing someone's barrier. The 0 of barrier is a ready-to-use value. How does this work? This, I'm assuming, is better documented. Could be used to signal a permanent state change, for example, signal to shut down. Oh, Chief of Beef. Thanks for following. Should definitely say hi in chat. Tell me what you're watching for. I know I do a lot of Go stuff. I have not been streaming it on this channel, but I hope to change that. And I wanted to do more of it because we finally got a low latency mode, because it helps to go through this stuff to actually talk through it. And when you have high latency with chat, it's really obnoxious. But there's low latency mode, so now you can actually talk to me and I can respond. Feel free to ask me, interrupt me about anything, Go stuff, whatever. Or even what I'm doing, because, you know, I'm sort of just casually working on this little prototype here. So forward will cause fall to be invoked. The implementation ensures that any reference to forward barrier. I see. Okay. I don't think that's used, but okay. Fall can be called any number of times and cause the channel returned by barrier to become closed. So this is just a fancy pattern around channels. And then there's a fall hook, which I guess is part of the point of this. But the forwarding, like, I'm pretty sure I could just do this with a channel. I think when I re-implemented this before. Chief from Slack. Are you talking about the Glider Lab Slack? I think I remember Chief. I need to check in on that Slack. I have not opened it in a little while. I was actually gonna post this stream on in there. How did you find out about this stream? Oops, that doesn't go anywhere. Alright, I think that was all that was interesting in here. Oh, I came here for this and I ended up looking at everything else. So this idea of an outlet factory, which I'm kind of confused by this naming, but basic idea is kind of like a log. I don't want to say log aggregator, but like a little in-process, yeah, log aggregator. And you pass it line readers, and it'll read full lines. Because that's the problem if we took all the sub-processes and we just made them write to the parent process standard out, most of the time it would work out okay, but there's always the possibility that they write at the same time, and then you have messages from one process being written in the middle of another's line, so this avoids that. But it looks like it has some stuff that's specific to Forgo, just like how they do error output and system output and stuff like that. I almost want just like some kind of other I/O interface, like, let's see, an I/O reader. Yeah, just like an I/O reader that lets you add new line readers to it. Let's see, does this... Okay, so the line reader you actually run in a Go routine. Buffer right. And then this is write line, which of course has a lock. And it's just doing a printf directly. Who dat? Let's see. Yeah, if I could give it a writer. Yeah, something where you can just pass it a writer so that I don't have to do this. Okay, okay. So it wouldn't be a reader. This is just a little, call it a line writer. And that gives us a lot of flexibility when we want to pipe to parent standard out or write to a log. Though this kind of going through writing the recent log output to a file is interesting. You need to think about how basically need to buffer the logs. So I wonder if there's any implementations of that we can look at. I can't think of anything offhand. Docker does it, but I'm sure it's a really big, complicated implementation. Let's see, like a log buffer in memory. Yeah, I mean, they're just... Oh, they're talking about using the actual log interface to do that. No, I don't want this. In memory. Okay, this. Okay, I like these guys. I don't know why we need all of this stuff, but... Oh, geez. Oh, I think the... Yeah, okay, this is their log spout replacement. Yeah, why did they stop using log spout? Fluenty. Whatever, I don't care. Okay, this isn't what I want. I want just like a... I mean, I could just use a buffer, right? Bytes buffer. Give it a... cap. Okay, so it's based on a... So I could create a byte slice. To size the internal buffer for writing. Should have desired capacity. And what happens when you write to it when it's at capacity? right? Appends contents of the buffer, growing it as needed. If it becomes too large, right, we'll panic. Well, I don't want that. With that capacity. What's this about? Nope. 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 Oh, come on. Looks like someone else made another one. Why did they do this? Supports a portion of string converted package 0 allocation formatters. What? Oh, like, I see. Well, that's kind of a weird thing. Okay, but okay. Sure. Yeah, this is not great. Oh, this is a bug. What do you call that? This is a, circular ring buffer. Okay, that's fine. Note that bytes, while inescapable at times, is expensive. Avoid. Okay, I need to read the docs for this. Why is it not easy to? Oh, jeez. This is dense. Where's the just like, I want to use it? Oh, this is interesting too, because I don't. Okay, let's see how read and write work. Cause let's look at write. Let's go back to an overview because I want to. Isn't there like a built-in implementation of this? Oh, but it's like, oh yeah, value. Okay, what's this? Armon. cool, cool. This is more my speed. Oh. But I can't read from it? I guess... Okay. No, this is what I want, because I would just write it out anyway, I think. I would just pull all the bytes out at once, so... Perfect. I'll use this for when we need to dump the... what's it called? Circ buff. For spitting out the recent log output on fail. Let's see. In theory, I can just have an API that you could wrap to do this sort of thing. Okay, so let's see, let me think about data structures. Kind of going top down here. Let's see, we're gonna have a command, we're gonna have a, let's see. Something like call it a sidecar. Probably have the command in there. Let's see what else. I was also trying to think if the watching the files. Well, you know what? I have done something like this before. Let me go look at that implementation. I think it was in here. Some crazy branch, maybe. Oh, I remember some of this crazy stuff. Oh, look, I didn't even really bother to do any of this stuff. This is just kind of sloppy. I see. I was doing something like this. Okay. What? Well, shit. Extra images. Oh, this is, okay. Basic auth. Oh man, okay, yeah. I rewrote this thing. This is another prototype. I should just get rid of these. Where do I go for... this. Let's see. What a funny little... That makes sense. Weird. Yeah, this is not doing any of the actual like watching stuff, so I'm wondering if the supervisor, the watching is just kind of a separate orthogonal thing. I don't know. I'm kind of idealizing this design too much, but for fun, why not? I mean, it seems like, oh, well, we should just design this supervisor and make it watch the files. But we're thinking, well, actually, supervisor, maybe this is actually generally useful in cases where you don't want to actually watch the files. And instead of doing like an if statement in it or something like that, you just have something else actually watch the files and then tell it to reload, you know, reload all or something. Because we need to read the directory and find executables. And then later individual events might reload the executable. Or we would tell the supervisor to reload it. Yeah, that seems like something that we can just put in the API and then have the watching be separate. And then reading the directory though. Could just feed it. I think that's what this does. Bunch of strings. For each Bronco run process. I'm doing a lot of upfront. This is how I design stuff. I do a lot of kind of upfront pre-planning and kind of building it in my head before I start building stuff. It really depends, because I know if I don't know what I'm doing, I might do a little bit of thinking and then start kind of messing around. But in this case, it's a very kind of knowable thing, and I've done it before, so I'm just kind of like refreshing before I don't have to mess around and hack around. So I'm able to put a little bit more time in up front because I have all these references that I can kind of look at and think about. See, there's another reference I was just thinking of. Oh, there's the let's see, what was this again? Serve. It was actually modeling them as services. Interesting. So I might do that for the supervisor. So the supervisor just implements serve and stop. I'll make a note of that. Notify watch. Oh. Wait, what? C? Watch? This is a different library. Okay. This must have been around before FS Notify. I think they referenced that project, right? Yeah. On steroids, what the hell? Active development. Okay, well. This one feels a little better. Oh shit. Oh, that's why. We don't have Mac OS support. That must be why. With KQ. Oh, I see. Thank you for pointing that out. I was about to drop this thing. See, that's why the stream is useful. So I should have just read this. Okay, but yeah, I wonder. Okay, well, whatever. Yeah, this is what I'll use. Luminism. Hello, welcome. Let's see. So that other thing I was kind of modeling it was with a map. So it was like you know, sidecars where it would be like a string to a sidecar. Maybe something like that. Ooh, we have lockable maps, right? I should probably sync map. Yeah. Unless I need to do, we'll see what else I have to implement because might just put a mutex on the whole thing. Mango Mammoth, what is a supervisor? What is a supervisor? Just kidding. No, but actually, process supervisor. Process supervision. Some master process remains the parent of service processes. All it is, I mean, this is in every system, something like this does this. Systemd is a supervisor. It's very complex, does a lot of things. There's some off-the-shelf things that people have used. Run it, on it. I've seen all of these used in production. Daemon Tools is a kind of classic one. Launchd is what's in OS 10. Most of these are designed to be the init process in a Linux or Unix system. This is not the init process in my case. I don't need a lot of the features that an init process usually needs. Python has a supervisor. Python supervisor, supervisor D. And so this is, right, it shares some of the goals of these init things, but it's not meant to be run as an init. So this is, useful for cases like your app is multiple processes and you want to run them all at the same time. And the main job of the supervisor is just to have policies for when the thing dies. So if it crashes for some reason, maybe it'll restart it. Maybe it'll restart after a wait. Maybe it'll do a back off. But its main job is to make sure things keep running. The concept in general is of process supervision can be generalized, and you talk about it more in like Erlang, which does that a lot. Where you have all kinds of patterns around process supervision. There's a great, where was this? Right, so when you build Erlang applications, it's basically a big process tree, because everything in Erlang is a process, and you have processes monitoring other processes, but you don't just have like one process monitoring all of them, because some of them have different patterns. And so these are the things that a lot of process supervisors, normal like Unix processes, Erlang processes, they don't have all of these patterns. So like one for one, one for all. So sometimes if one of your processes dies, you just want to replace it. Yeah. Sometimes if one of your processes die, it means you want to replace all of them. Sometimes a rest for one is a weird one. It'll replace all the ones that came after it. One for all is a really interesting pattern that I used a lot for building containers. So containers, I might run multiple processes in them, but I want the whole container to fail and die, so that it can be rescheduled or something if one of those inner processes work. So I had to build my own process manager that does the one for all pattern, because all these other non-init supervisors aren't designed for that. For some reason, they don't have that kind of pattern, because they all assume you just always want to run all the processes, and if it stops, you just restart it. So in my case, this supervisor is a very special case, and this isn't even a standalone supervisor. This is a library, so that I can create a program that will then supervise some child processes. Those child processes in my case are like plugins or something like that. And so that's kind of the main purpose of this. Sidecar supervisor made to run daemons alongside your main process. We call them, they could be plugin daemons, maybe they're not. So in this case, we just have a place where we're going to look for executables, whether it's a executable binary or shell script. We watch, we take all the ones that we can execute, we start them up, we run them all, we watch that directory. So one of the interesting things now, if you change any of those files, it'll reload this service, so you can kind of do more real time as you're working on the plugin. You can continue to run the app, and you can see it run the new and we're gonna log everything to the parent standard out. Let's see, leave it right reset. Yeah, and some of these are kind of like extra. Yeah, start new daemons. Let's see, could I use a channel? Let's see, what were we talking about there? Yeah, it's kind of rare that, I don't know about that. When, just an observation, not necessarily you, but in general, a lot of people when they start learning Go, they get fixated on channels because it's one of the newer concepts that the language introduces. But channels are really cool, and thinking about building parallel programs and parallel algorithms with channels is really cool. But most day-to-day work with Golang doesn't use them that much. Use them for signaling, use them for like as an event queue. There are a couple of patterns where you use them directly, but a lot of the time you do end up just using mutexes, especially as a library author, because a lot of the time you're using a mutex because you have some state that you need, and you have all these methods that you need to make thread safe. So let's see, I was trying to think. Oh, we're gonna have some kind of writer. That it'll read all the logs in and write to this. So maybe this is standard out. I don't know if I care about standard error anymore. Go routine everything. Kind of same thing with Go routines. Like it's another kind of thing where it's very easy to just make everything a Go routine. That's just asking for trouble. Do I care about standard error? I mean, obviously I'll read standard error from the subprocesses, but I don't think I care about standard error. Good question. So when a child process dies, it signals the supervisor that it died. That's... Actually, I think when you fork... Yeah, if you're using forking, you might be able to get the signal back, but we're not... Or at least the implementation that we're using, we don't have that, and it's usually better, because what if it doesn't signal for whatever reason? So it's usually better to kind of pull for the thing. So most things are just gonna wait for I think the built-in exec package in Go just has a wait, and that waits for it to die. So you just kind of imagine putting that in a loop where it starts it, waits for it to die, and then it just runs it again. So it's actually a lot simpler than doing a signal back to the parent. Let's see here. Some of my examples, because I'm kind of re-implementing stuff I've done, stuff other people have done, but Yeah, I'm trying to find a good example. It runs the gateway co-process. Oh, here it is. So here, that's sitting in a loop and just starting a new process and whatever. Let's see, this is another implementation. Oh, that's interesting. This was designed in a case where I model the command as a service, and then I can put this in. There's a library that actually models a kind of Erlang style process tree system, and you can just add objects to it that implement serve and stop. And so, and it has restart policies. So if serve was to return early, then it would just call serve again and do a back off. So that's putting the restart logic somewhere else, but that's sort of assuming that you're part of a framework using that. So in this system, I am going to want to do my own restart loop, which, you know, I'm thinking just having a let's see, just having kind of it'll try and restart immediately. And initially I'm just gonna like restart immediately and not do any kind of back off if it doesn't. I mean, that's kind of crazy though. Maybe immediate with 3 retries, something like that. We're gonna worry about our passing signals along. I think Forgo has good code for that. Let's see, where is that? Outrun. Monitor interrupt. F tear down now. Oh, that's interesting. If first. Fall through. Okay, that's funny. Okay. It's like, oh, there's a special case, but then actually just do the default case. So, tear down fall. Fall now. Okay, so it always, if it's not first, tear down now. So I control C. It's just going to do tear down fall. If I do control C again, it's going to do tear down fall and fall now. So then it goes here. And in here. Oh, I guess, yeah, so it ignores that and it just goes here. Okay, let's see, what's finished? Oh, finished is our... do a wait group. Oh, this is waiting for all of them. Start process. F wait group add. Oh, so we have a finished for this, we have a wait group for everything, and type weight. Oh, we're waiting. I see. We're waiting for standard error and standard out to finish. And we do a wait. Yes. Oh, I see. These are defers. Okay, so first close that, and then do that. Okay. Yeah, I'm probably going to do something very similar to this. This is not. This is just doing interrupts. It's not doing a. It's not proxying signals. I don't think I care about proxying signals, though. To be honest, just care about. Well, that's funny. If it's any of these, I guess that's fine. If it's any of these, it's gonna try and kill them with a regular kill and then a sig kill. Send sig kill. PS process. That's this process, right? What is that process? Right. Signal. There's something. Oh, it's interesting. What does it do on Windows? Okie dokie. Yes. What do we get in here? We get event which is relative path to the file directory. Okay, so it's not giving us anything fancy. Get renames. So if I move a file, it's going to give me a rename event. I'd like to think so. So maybe this is based on file path. Let's see, do I want to have a persistent sidecar, or do I want to create a new sidecar every time? think I want a new one every time. And I should see, let's see, I don't have a testing strategy. I'm guessing I would create like, oh man, there's a foo process and it returns, foo lines of foo. I guess what are the different cases I'm thinking here? What would I test? That the output does get written. I'd want to test the on crash. It's kind of making me think of the ways that it's going to communicate with the supervisor. Could just give it the writer. Some kind of log thing. Alright, I might need to start writing code soon. Just kind of a rough sketch because I was going to wrap up at 7 and then continue this on Thursday at the same time at 5 p.m. Central. So that's good. I'm kind of mapping it all out here, trying to think of what else. Sidecar runs. Yeah. Well, so I did a little work up front, you know, looking at how the exec package does their tests. So I don't know if you saw this, but instead of mocking exec command, a lot of times people will just do this setup. So these are some helper things that give you a command that kind of wraps it. Instead of running the command that you wanted to run, it'll basically run it pointing to the test binary itself and telling it to run a particular test. And then that test is this test. So this becomes an entry point for the child process. And so it makes sure that that's how it's being run as. And then you can just do like a switch here and pretend to be any of the child processes that you want to be. And then command works as usual. So you can test the output and stuff like that. So I was wondering, because it's not that important for me that command is run, because I know command works. So I was wondering if I wanted to mock exec command, but it's easy enough to do this that I just figured why not do the real thing. Everybody else does. But so there's different levels of testing. So I'm thinking, how do we test sidecar? How do we test supervisor? Sidecar doesn't really do much. I'm trying to think, does sidecar need to exist, or can we just have a command? because it has a path. If we're making a new one every time, I guess we do want to be writing to our files. Let's see. It's possible we don't need a sidecar struct. For example, for Go, which is doing something similar, and they don't have one either. They just have a start process. All right, I'm gonna simplify that idea for now. Sidecars. Let's see what I'm thinking. Let's see, line reader. I think I do want a separate basically a line writer. That I use kind of like their outlet factory, which is a kind of strange name. So I can test this, ultimately putting a buffer here. Let's see what else. I guess we could generalize this. We can create a little program. Instead of foo, it would be like an echo stream. I mean, we could just do echo, which is let's see, return args, return standard in. I don't know. Echo stream, we could repeat the args, and that's probably enough to test. Oh, I guess we need some programs that will crash. So you want things that crash immediately, so this is just going to do an exit. We want maybe something that can test a panic. Oh yeah, writing to files. So how's this thing going to write to a file? So this line writer then would need pipe weight. And it reads and it puts it in the buffer. I'm guessing, so it's gonna read, and then we can do a multi-read into not this. Well, where the read will write into this buffer. Is there something like that? I don't know if there is. A read writer. It's not what it. where for every read it does a write. So it's not a multi-reader. T reader. Returns a reader that writes what it reads from R. Perfect. So we wrap it in T reader. And so if this is managing it, then we'd also have with the same key something at I guess it's a circ buffer, so new buffer. All right, so a pointer to a circ buffer. So this would have reload. Reload all for fun. Takes the path. This buffer, if I do a bytes slice of bytes written, does that reset it? It's unclear how this works. Oh boy. Slide should not be written to. So it doesn't look like it resets anything. So I guess that's cool. These are internal anyway, so. Maybe this is public. I don't know if I'm going to implement the server interface just because I might want to do like stop and stop all. So I want to see this now. is error. Right line. It doesn't seem to care, just to stand out. That's fine. So we have the line writer, and it's gonna basically do something very similar. Line writer. Wait. I guess this has a pointer to. Yeah, I'm gonna make this easier so you can't change the writer after you create it. This becomes easier because it's that, or rather this is a line writer. So we want it's going to be read lines. Error output. See what how they were doing that run. Let's see, error output. Where do they use error output? Singleton. Oh, that's like the input. I see. Run start. Okay, from here I can do, let's see, new. So we can add something new by just calling reload. So when I start, I can say new supervisor. Here's all the paths. Or I can just call the paths. Huh. You start several times. Now we're getting to the point where it might need its own structure. Because we're basically just creating a map for every piece of state here. Okay. I feel like I could implement this pretty quickly now, but it's 7 o'clock, so I'm going to save this. There is a project for this that the code does not exist in yet, but I'm using prototypes on my GitHub, so if you want to follow along there or something. But I'll be back on Thursday to basically implement this now. Yep, I think that's it. Alright, so it's probably a lot less Go code than I think people were expecting, but this is how I build stuff. So had to be done. Come back on Thursday and we'll actually write some Go. Alright, thanks everybody for watching and hanging out. Bye.